Aquifers are rarely underground lakes like you might see in a cave. They are typically rock formations that are mostly solid, but like sponges, they have interconnected fissures and pore spaces that hold water and allow it to move within the formation. An aquifer is best defined as a layer of saturated rock and the water in its pores. Aquifers are formed very slowly over vast periods of time. Water in aquifers comes originally from the surface of the earth. When rain falls, some of the water infiltrates underground and collects in the pore spaces. Water in rivers and lakes can also seep into the subsurface pores. Eventually, some interconnected pore spaces become saturated with water. In other words, they become an aquifer.
The ability of an aquifer to produce water depends on the properties of the aquifer's rock formation. The two most important properties are porosity and permeability. The porosity is a measure of the volume of empty space, or pore spaces, inside the rock. Pore spaces can be openings between grains, fractures in the rock, and even caverns. Porosity represents the volume of water a rock formation can hold. Porosity itself isn't enough to create an aquifer. The areas filled with water must connect with each other so the water can flow from one pore space to another. That connectivity between pores is known as permeability. Permeability is a measure of how readily water can flow within the rock. Rocks such as pumice and shale can have high porosity, but do not form productive aquifers because the pores within the rock are not connected. The permeability of pumice and shale is low. On the other hand, gravel transmits water quickly because of large connected pore spaces. The permeability of gravel is high.
Compared to water movement through rivers or lakes, the rate of movement through an aquifer is slow.
Managing groundwater is the same as managing any budget. A household cannot continuously spend more money than it earns. In the same way, an aquifer cannot continuously give more water than it is taking in.
Accounting for the groundwater budget requires thinking about the water cycle. The water cycle is the continuous movement of water on, above, and below the surface of the earth. Water that enters an aquifer from the surface is called recharge. Recharge includes rainwater that seeps down through the soil to reach the water table. Only a small portion of total precipitation gets down this far. Recharge also includes water draining into the aquifer from streams and lakes. Water that enters from another aquifer is called inflow. Inflows and recharge are comparable to a deposit in a bank account. They add to the overall wealth of an aquifer. Water exiting an aquifer naturally or artificially is called discharge. Examples of naturally occurring discharge are evaporation, groundwater used by plants, springs, leakage into streams or lakes, and leakage from one aquifer to another. The most common discharge from an aquifer by humans is pumping. Discharge is comparable to a withdrawal from a bank account. The amount of water inside an aquifer is called storage. This is comparable to a balance in a bank account. Anytime we pump water from an aquifer, we are drawing down the water level in the aquifer storage. As long as the amount of inflows can replace what we pump, drawdown is temporary and does not affect water availability. When inflows can't keep up with pumping, we are depleting the aquifer. Prolonged pumping in excess of inflows reduces the amount of water in the aquifer, and as a result, pumping becomes more difficult and costly, as water must be lifted from increasing depths.